In my last video, I successfully 3D print a gummy bear model. Before we begin, I'd like to introduce my 3D printer to new viewers. Unlike traditional FDM or resin printers, this printer uses inkjet printing technology to print by jetting resin. The ultimate goal of this project is to achieve full-color 3D printing. However, for overhanging structures, support materials are still necessary to ensure successful printing. Why are support materials needed? In PolyJet type 3D printing, if a structure lacks sufficient support underneath, the printing material may collapse due to gravity, leading to print failures. The support material must be easily removable after the final model is formed, without affecting its quality. During the development of support materials, I tested many different formulations. Some materials were too tough and difficult to remove. Others were strong but not suitable as detachable support materials. So, I continuously adjusted the material composition, trying to find one that could provide stable support while remaining brittle and easy to remove. After multiple trials, I finally developed an ideal support material. It is very brittle, making it easy to break away without damaging the final model surface quality. Before moving on to the printing tests, I'd like to thank this video's sponsor, JLCPCB. In this project, I designed and manufactured my printhead driver board with JLCPCB. If you also need custom PCBs, simply visit jlcpcb.com, click Order Now, and upload your Gerber files to place an order quickly. JLCPCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. Don't miss JLCPCB's 6-layer PCB special. Get $30 off with a coupon and enjoy top-quality 6-layer PCBs for just $5. Since the support material is very fragile, I need to place it on a glass surface to avoid breaking it during handling. Compared to the previous material, this one also has a slight elasticity. Additionally, I want to test its water solubility, so I prepared a 1M sodium hydroxide (NaOH) solution to see if the material can dissolve, making post-processing even easier. After 2 hours, the surface of the model begins to absorb water and swell. After 4 hours, the model has visibly expanded, with a noticeable increase in volume. After 10 hours, the model starts to dissolve, and its volume begins to shrink. After 20 hours, the model is almost completely dissolved, leaving little to no solid structure. To print complex models, I need to use two inkjet printheads simultaneously. However, my current i3R modified printer is not capable of supporting the next phase of my research. So, I will redesign a new printer to support more advanced printing tests. Thank you for watching.